Hello everyone. In this tutorial, I'll be going over how you could use Lidar technology in your SwiftUI app to scan your surrounding and generate a .obj model that you could potentially use in an augmented reality app. So I got this idea from this guy called Tokyo Yoshida on GitHub, and he has like a lot of very cool applications of AR, and he put it in this one repo over here. And today I'm going to create a modified version of this, of the export scan object to .obj file. But of course, my video would be substantially different from this guy's because this project was written in UIKit and I'm going to write it in SwiftUI. And instead of sharing the model over here for this repo, they actually end up sharing the model as a .obj file. But in this lesson, I'm going to teach you how you could display it in your app. So you could display this model over here in your app. Okay, cool. So let's get started and create a new Xcode project. I don't know why it moved over there, but okay. Let's call this um, AR creating LiDAR model. Okay, and I'm gonna use SwiftUI in this application. And save, just save it here. And one thing to note, this actually requires a physical device in order for you to test this application. And not only any iPhone, you need to have like iPhone Pro or above. So I'm pretty sure that only some iPhone models and iPad models have LiDAR in it. So you gotta make sure that before you start the project, know that you could have access to a phone where you can actually test out the the application, right? Look over here. It says it's only available to iPhone 12 Pro, Pro Max, etc., and on a few selected iPads. Yeah. Okay. So, assuming that you have a Pro model, let's get started. Um, cool. So first thing we want to do is create an app delegate adapter that checks to make sure that your phone supports this ARKit application. So in order to do so, you can create a class called app delegate. This is like an adapter, basically. Delegate. Because usually like app delegates they belong in like the old Swift lifecycle, SwiftUI lifecycle. And since it's been a while since we transferred over to the new lifecycle, we still have to use this app delegate adapter for now. So to do that, just copy the code over here. This is quite time consuming. This code over here, you don't need to memorize it because I always just go on Stack Overflow and copy this code anyway, so it's okay if you don't know what it means. Okay. Okay, so this part is what you actually need. You have to create an if statement that says if AR world tracking configuration dot supports frame semantics there, and go for scene depth. So if your device doesn't support AR tracking configuration for scene depth, then print out, just find a way to handle um like for non-supported devices. And as always, in this function, return true. And last but not least, don't forget to include the adapter over here, or else it won't work. So app delegate.self. Wow, I can't type today. Self. Okay, so this is good. Cool. Now we have that set up. We could start building our project. So the first thing I'm going to do is I'm going to build um the AR model. So I'm going to create a new Swift file. Let's call this AR wrapper. And in order to build the ARKit, we have to create a UI view representable. So instead of importing foundation, I'm going to import SwiftUI and RealityKit and also ARKit. Cool. So I'm going to start creating my struct for AR wrapper. So this will be of type UI view representable. And over here, I'm going to create my required function. So make UI view, uh, and also update UI view. And instead of UI view, I'm going to replace this with AR view. And I'm going to declare a new variable that basically initiates this AR view frame.0. And make UI view, there's really nothing here, just return it. The meat of this AR view is in the update UI view box in the function. So Um, let's also change UI view type to AR view. And I'm going to leave this blank for now because we also need another class called, actually, I'll do that later. Yeah, I'll do that later. Okay, but going back to my AR wrapper, I also need to create a few methods, a few private methods that are needed to build the AR model. So the first one is creating a build configuration method. Build configure, and it's gonna return an AR world tracking configuration. Over here, I'm going to initialize configuration AR world tracking, and I'm gonna define some properties. So configuration dot environment texturing is equal to there's automatic and manual. I just choose manual because I don't want to deal with automatic personally. And over here, we also want to set configuration.scene reconstruction that's equal to .mesh with classification. So as you can see, it says an approximate shape of the physical environment, including classification of real world objects within it. So we're gonna select this one and gonna set another property. So AR view is going to automatically configure session, and that would be false. Honestly, you could play around with these attributes and experiment and see which suits you the most. But I played around with it over like the past 2 days, and I feel like all the things I'm doing here works perfectly. Okay. configuration dot frame semantics is equal to dot theme depth. So this is basically going to read in the basic surroundings and then using the LiDAR sensors create like a depth map, basically showing how close you are away from a physical object, and it's going to create that. Okay, I'm going to return configuration. Configuration. Wow, I can't spell. Okay, and next step is to create another private function, private method called, um, I believe it's func set AR view options. AR view, and it's going to pass in a parameter of AR view. Over here, we want to set the debug options um, to show that there's like to show scene understanding. If you want like an in-depth explanation of what each one does, you could refer to the Apple documentation because I feel like this thing that was released, I mean, ARKit was released pretty recently, like within the last 5 years, 4 years. So the new Apple documentation is actually better than what they gave us early on. So you could use that to your own advantage. Cool. Okay, now we go to our update UI view and pass in these. Set AR view options and pass in your AR view. And also the configuration is equal to build configuration and then set the configuration on the AR view like this. Okay. Does not conform to UI view representable. Oh, of course. Why is the sum here? Okay. Yeah. I'm gonna try to build it and the error should go away. Yep, I think it succeeded. Okay, cool. I'm going to go back to my content view and create my UI view representable in here. So I'm going to create a VStack and AR view, AR wrapper is what I've named it. And over here, we want to create a button called export to export the AR model. I'm going to leave this blank for now, but let's go back to our AR wrapper and create a new class called export view model and as object, and I'm gonna make it an observable object, and AR session delegate. I'm going to create let's see. I am going to create a function called convert to asset, and it's going to take in a few parameters. Mesh anchors, camera, and it's going to return an MDL asset. So basically the MDL asset is an index container for basically like 3D objects and information such as transform hierarchies, meshes, cameras, and light. That is according to Apple. That's the official definition. Okay, cool. Or let device is equal to MTL create system. Otherwise, you're going to return nil. The asset is equal to MDR assets. And for anchor in mesh anchors, this is like the point where it's going to detect a change in the shape. Mesh is equal to anchor dot geometry dot to MDL mesh. This is gonna take in, right, I have to define this. So to MDL mesh is actually something that I've created myself with the help of Stack Overflow. So I'm just going to paste my extension in another file, and I will probably link like a GitHub gist for you to access, so it'll be easier for you to copy. So I'm gonna create an extension called mesh dot mesh plus ext, and over here I'm going to paste my new extension that I've created. So we'll be using this one. Cool. And of course, yeah, I will link in the description below. Okay, now going back to what we left off on, this is going to pass in a few parameters, including, let's see, the first one is going to be devices. Going to pass in device, camera, and anchor dot transform. Yeah. And of course, we want to return the asset. Okay, and this is converting it to an asset. Now we actually want to create a method that exports the asset. And I'm going to use file manager in order to save the file on the app. So if you don't know, Swift has a, a pretty nice feature called file manager that basically stores local information and local like images on the client's device. And I will be using this method. So file manager.default.urls for document directory. Oh my god, I messed up here. Document directory. So let's say it's in a home directory, and I'm gonna pass in user domain mask. And we want to make sure that if this doesn't exist, then we want to throw an NS error that states the domain dot creating. I'm just gonna pass in my project name over here. This doesn't really matter, it's just for me to debug if something happens. Okay, so assuming that directory exists, I'm going to create a new folder. Let's just call this obj files. Basically, it's going to be the files, like the augmented reality files will be saved under this folder. And let's create a folder URL, appending path components, folder name. Okay. And over here, we want to try saving, try creating a folder if it doesn't exist already. With intermediate attributes, nil. And if, so let's say we've created our directory now, we want to create a unique URL that points to the file that it will be saved. component. So in order to create a unique file, a unique file name, I'm going to use UUID, oh, UUID, UUID dot UUID string because that will give me a unique file name. And we're gonna save it as of type .obj. What did I do wrong here? Oh, I missed. I added the extra quotation mark. Okay, so our file name would be a random UID string, and then I'm gonna put my extension over here. Cool. Now we want to actually save the file. So we want to make sure we want to incorporate a try, a do catch block just to handle errors over here. So we want to export as a URL and we're going to print object saved successfully at the URL location. It's just going to return URL. Over here, of course, we're going to need a catch block. We're just going to print error. And last but not least, return a default URL. Okay, this is all looking good. Now we want to go back to here. No, actually want to go back to content view and initialize a new uh, state variable. Let's call this submitted export request is equal to false. So over here, let's say submitted export request dot toggle. Cool. So what this will do eventually is that once you press the button, it will export the current model that is displaying on the AR wrapper view. Okay, so let's go back to AR wrapper real quick and define a few binding variables. So we want to listen from content view, and if submitted export request is called, we're going to execute a new task. We're also going to want to have an exported URL. Okay, and over here in our update UI view, I'm going to have an if statement. So if submitted export request is true, then I will try to execute my saving process of the file. So this is pretty self-explanatory. You're trying to get the current frame of what you already have as the LiDAR model, and you are going to save it as a file. So you're going to get the mesh anchors of the current model, frame.anchors.contact map, and here for each of them, okay, AR mesh anchor. I need to have curly bracket here. Once we have that done, we also want to create a second let statement. Is equal to, I should probably create a new variable referring to my export view model. I'm all over the place right now, I'm sorry. Export view model. So here we could actually call the method that we defined earlier. And for mesh anchor, we could set it to the returning value. And for camera, we're gonna set it to camera. Okay, and we're gonna open up a do catch block over here. So we're gonna try and save this by exporting it to our local directory. And yeah, asset, export to asset. And I'm just going to do this real quick. Export to asset, export URL is equal to URL. This is kind of extra, you don't actually need it. And anyways, if you have an error, if you run into an error, you're going to print out export failure. Ha ha ha. Okay, now going back to content view, you're going to see that the compiler won't be happy because we'll be missing some arguments. Exactly. So over here, I want to pass in submitted export request and exported URL. I forgot why I did this, but I don't think export URL does anything. It's okay. Exported URL. Cool. I'm gonna add some padding to this thing, and it should be looking good. Oh, yeah. Add an optional there. And yeah, this is looking pretty good. Um, oops. One more fix here. And yeah. Okay, so this is the moment of truth. You want to pull out your physical device that has the LiDAR sensor, connect it to Xcode, and run it. So I'm going to do just that before before doing that. I'm going to fix this real quick. And the last thing you have to do is go to info.plist and you have to add camera permission. So let's add a new key over here, and let's find privacy, and then hyphen camera usage description. And let's just say using camera for LiDAR. Okay, so yeah, let's build and run. Make sure you have a physical device connected and run it through there. And also make sure that your device is like a pro model and has the LiDAR sensor on your device. So I'm going to do that right now. Alright, we are now on the iPad and we are greeted with the alert saying that they would like to access our camera. So obviously we're going to click yes, and there you go, our camera. So, well, this is my setup basically, but as you can see, it scans the surrounding area. And if I move further away, it's still able to pick up the surrounding area. So this is very powerful and could generate a .obj model. Well, obviously I'm not going to show you my whole room, but this gives you a basic idea of how this thing works. And yeah, I'm just going to get the edges in. Okay, there we go. So, and next next, I'm gonna click export and pay attention to your console because it should say saved successfully. There. Okay. And sure enough, as you can see, it says object saved successfully at the file location. Cool. So in this video, I'm just going to start right here. And in the next video, I'm going to show you how you could display this current file that you have over here. So I've done this a few times and this was one of my files that I had. So we're basically going to display something like this on the on an iPhone or iPad. And it will definitely be more adjustable too. So yeah, stay tuned for the next episode, I guess. I hope you enjoyed this tutorial and I'll see you in the next one.